Bismillahirrahmanirrahim. This is Dr. Isma, and today we shall be doing the physiology of temperature. We as humans can discriminate different grades of cold and hot temperatures, from freezing cold, to cool, to indifferent, to warm, to hot, to burning hot. These different grades of temperature that we discriminate depend on three types of receptors. Number 1, cold receptors. Number 2, warm receptors. And number 3, pain receptors. And the pain receptors are only stimulated by extreme degrees of heat or cold. And these pain receptors, along with the cold and the warm receptors, are responsible for us feeling freezing cold and burning hot sensations. These cold and warm receptors are located immediately under the skin, and these are present at discrete separate spots, and it is believed that there are 3 to 10 times as many cold spots as there are warm spots in most areas of the body. And the number of cold spots in the lips is about 15 to 25 per square centimeter or per centimeter square, and the number of cold spots in the fingers is about 3 to 5 spots per centimeter square, and at some broader areas of the body like the trunk, the cold spots are about 4 centimeter per square. Warm signal transmission occurs via type C nerve fibers, and the transmission velocity of these nerve fibers is 0.4 to 2 meters per second. Cold sensation is transmitted via specialized small types of A delta myelinated nerve endings, and these small A delta myelinated nerve endings branch several times, and the tips of these endings protrude into the basal surfaces of the epidermal cells, forming definitive cold receptors. These A delta myelinated nerve endings transmit cold sensation at velocities of about 20 meters per second. However, some cold sensation are also transmitted via type C nerve fibers. Once the thermal receptors are stimulated, one can feel about 5 sensations, which have already been mentioned, and these are cold, cool, indifferent, warm, and hot. The 4 types of nerve fibers that are present respond differently to different levels of temperature. The pain fibers or the cold pain fibers are stimulated at very cold temperatures. This stimulation of the pain cold fibers ceases when the skin becomes very cold or nearly freezes, and the stimulation of these cold pain fibers also ceases when the temperature rises to about 10 to 15 degrees above freezing point. Then there are the cold fibers. These begin to be stimulated at temperatures of 10 to 15 degrees Celsius. They reach their maximum stimulation at 25 degrees centigrade, and the stimulation slowly fades out above 40 degrees centigrade. Then we have the warm fibers, which begin to be stimulated at temperatures of above 30 degrees Celsius, and their stimulation fades at 49 degrees centigrade. Finally, at extreme degrees of heat, which is about 45 degrees Celsius, again the pain fibers are stimulated, and then some of the cold fibers also begin to be stimulated, and this is not because of feeling of cold, but it is because of damage to the cold endings by the extreme heat. So basically, one determines the different grades of temperature by the relative degree of stimulation of different type of nerve endings. And both extremes of temperature, which is burning hot and freezing cold, feel almost alike, which is pain. This figure has already been explained, but let me explain it again. As you can see from the figure that the four different type of nerve fibers being stimulated. The dotted blue line is the cold pain fibers. The bold blue line is the cold receptors. The dotted red line is the warm receptors, and the bold red line is the heat pain fibers. So the cold pain fibers are stimulated at extremes of cold, but their stimulation ceases or decreases around 10 to 15 degrees Celsius. Then you have the cold receptors. Their stimulation increases around 10 to 15 degrees Celsius and reaches a maximum at around 24 degrees Celsius. But their stimulation also decreases around 40 degrees Celsius. By around 30 degrees Celsius, the warmth receptors start to be stimulated, but their stimulation also decreases around 49 degrees Celsius. When the temperature is about 45 degrees Celsius, the heat pain fibers begin to be stimulated. Also, you have the stimulation of the cold pain fibers in this range of temperature, and this is not because of cold sensation but because of damage to the cold pain fibers by extreme degrees of heat. When cold receptors are suddenly subjected to a fall in temperature, they become strongly stimulated at first. But this stimulation gradually fades away but does not completely stop even after 30 minutes. So this indicates that the cold receptors adapt, but they do not adapt completely or do not adapt 100%. And this is the reason why one feels extreme degrees of cold when one moves from a heated room to out of doors on a cold day, but then stops feeling extreme cold if the person stays outdoor for some time. Same is the case in case of temperature when the temperature is rising, that a person feels very hot when entering a hot tub of water, but then gradually becomes used to that heat. So this indicates that the temperature receptors respond more markedly to changes in temperature than when the temperature remains at the same level. Warm signal transmission occurs via type C nerve fibers, and the transmission velocity of these nerve fibers is 0.4 to 2 meters per second. Cold sensation is transmitted via specialized small types of A delta myelinated nerve endings, and these small A delta myelinated nerve endings branch several times, and the tips of these endings protrude into the basal surfaces of the epidermal cells, forming definitive cold receptors. These A delta myelinated nerve endings transmit cold sensation. The number of the cold nerve endings or the warm endings in any one surface area of the body is usually slight. Because of the small number of the receptors, it is very difficult to judge the different grades of temperature when small areas of the skin are stimulated. The judgment of different grades of temperature in the body surface is directly proportional to the area stimulated, which means that if smaller area of the body is stimulated, the judgment of the temperature will be poor, while on the other hand, if a bigger area of the body is stimulated, the judgment of the temperature will be much better. And this is basically because there is spatial summation of the thermal sensations. For instance, rapid changes in temperature of as little as 0.01 degrees Celsius can be detected if the change affects larger areas of the body at the same time. And conversely, changes 100 times as great will not be detected if the affected area of the skin is small, meaning about 1 square centimeter in size. The thermal signals are transmitted in pathways which are parallel to those for the pain signals. Once these thermal signals enter into the spinal cord, the signal travel for a few segments upward or downward in the tract of Leschur. Then they terminate mainly in lamina 1, 2 and 3 of the dorsal horns. These lamina of the dorsal horns also receive pain fibers. After this, the second order neurons arise and they cross over to the opposite anterolateral sensory tract. These ascending fibers, that is the second order neurons, then finally terminate mainly in the reticular areas of the brainstem and the ventrobasal complex of the thalamus. Some of the thermal signals are relayed to the cerebral somatosensory cortex from the ventrobasal complex. This is the S1 area of the cortex. If entire cortical postcentral gyrus is removed in humans, it does not completely abolish the sensation of temperature, but it just basically reduces the ability to sense different grades of temperature, because mainly the perception of temperature occurs at the level of the brainstem and the thalamus.